Let's take a look at derivatives and what they actually are. So jumping right into that, the definition of a derivative is the derivative of a function, I should say, is the instantaneous rate of change. So the derivative we can write as the instantaneous rate of change of a function. So it'll always be defined relative to a function. And if you remember when we talked about instantaneous rate of change or rates of change, we always said that was going to be the rate of change of something compared to the rate of change of something else. In this case, it's the output, the f of x, with respect to the input, or x. So if we use a standard y equals f of x function, there's 4 ways that we can express this. Don't worry about exactly why we're writing what they are. Just write these down because you're going to see all 4 of them throughout the year. And as we go on, it will be clear why we use each of them. And I'll kind of point it out as we go. So the first way that I can write the derivative of the function y equals f of x is f prime of x. The second way that I can write it is y prime of x. The third way I can write it is dy by dx. And the fourth way I can write it is d by dx of f of x. So again, that was f prime of x, y prime of x, and this is just a little apostrophe up here. Then dy by dx, so just, dy reading the top, by for the division, dx for the bottom. Fourth one, d by dx of f of x. So again, we'll get into details of what those mean and why we write them that way later, but now you've got the notation. So a derivative can be calculated for a specific point or for an entire function. So I can find the derivative at a point by saying the derivative of f of x at a is. I can also say the derivative for the entire function, the derivative of f of x is, and then say a function. So either the derivative can be calculated for a specific point, getting a specific value, or I can get a function, and we'll look at those in a minute here. So the derivative function, so that second option from that previous slide, that's going to define the instantaneous rate of change for every point on the function. So I could just calculate the derivative at an individual point and say, I've calculated it, here's what it is. Or I can get the derivative function, which will tell me, as a function itself, what is the rate of change at all the different points. So for example, if I have the function f of x equals x squared, and the derivative function f prime of x equals 2x, don't worry where I got this, just know that this is the derivative of that previous one, then that means the instantaneous rate of change at x equals 0 is going to also be 0, because I can plug it in here. The instantaneous rate of change, or the slope at x equals 1, is going to be 2. The instantaneous rate of change at x equals 2 is going to be 4. And the instantaneous rate of change is also the slope of the function, so you can test this. If you graph x squared and you find all these, all these slopes, you can see at 0 the slope is 0, at 1 the slope is 2, at 2 the slope is 4, etc. Okay, so let's actually talk about the definitions. We've talked about it in words, now let's talk about it in math. So in a video before, you saw the definition of the instantaneous rate of change. Well, if the derivative is the instantaneous rate of change, that means that the derivative in math is just going to be the instantaneous rate of change. So before we saw there were two forms. We labeled them the general and the alternate form. So this is the general form of the derivative, and this is the alternate form of the derivative. Basically, they're both for calculating the derivative. The general form can find derivative functions and at a point. The alternate can just find the derivative at a point. So that's why we kind of use them. Generally speaking, the second one is going to be slightly easier for finding a specific derivative at a point, but the first one will let us find derivatives for functions as well as at a point. So that's why we have those two forms here. Let me know if you have any questions. Otherwise, you can kind of jump into your next step.